So today we answer that age-old question, what is a vector? A vector is a specific quantity drawn as a line segment with an arrowhead at one end. Vectors always have an initial point and a terminal point. Vectors are determined by magnitude, which is the length of the vector, and direction, which is indicated by an arrowhead at the terminal point. So let's take a look at what these like when we draw them. So we have our xy coordinate plane that our vectors will appear in, and we have some initial point in space, and we have some terminal point, and we have a line segment connecting those 2 points, and we place an arrow at the terminal point to indicate that it is the terminal point and that is the direction this vector is heading. The magnitude would be the distance from our initial to our terminal point. Mathematically, there's many symbols used to represent vectors. Most commonly, you'll see lowercase italic type, such as VUW. And you also will see a lowercase italic type with a little arrow over top of it. Those mean the same thing. They're both indicating you're working with a vector. In the book, they use some terminology with initial point P and terminal point Q. And when we are given an initial point 0, 0, the origin, and some terminal point in ordered pair A, B, we may write A, comma, B with these pointed brackets. So the pointed brackets indicate we're working with a vector. And when we see this symbol, it does have a special significance mathematically. This indicates the standard position for the vector you're working with. So to graphically represent these things and also to calculate this standard position, we take out this little picture provided by the textbook here. And in this picture, we have an original vector labeled CD, and we have a position vector labeled AB here in red. Notice that AB starts at the origin and has a terminal point of A, comma, B. To calculate the position vector AB from a given vector, in this case CD, we take the second x-coordinate minus the first x-coordinate, comma, second y minus first y, and that gives us our AB. Working with an example now, consider the vector whose initial point is P23 and whose terminal point is Q64. So looking at this PQ notation that I mentioned earlier. Over on our graph, we notice here we have our initial point P at 23, our terminal point Q at 64. And what we're trying to figure out is how to get to this red vector, the position vector. So we take our second x-coordinate 6, subtract it from the first, which is 2, the second y 4, and the first y, which is 3. 6 minus 2 gives us 4. 4 minus 3 gives us 1, and our answer here is the position vector represented by V equals 4, comma 1, surrounded by those pointed brackets to indicate that it is a vector.